In this session, I am going to explain Tower of Hanoi. This is a puzzle where I am explaining, and this is here I am explaining how Hanoi is implemented using C function, that is using recursion. Here now let us see what is the Tower of Hanoi. Tower of Hanoi is one of the main application of the recursion. It says if you can solve n minus 1 case, then you can solve the nth case. It is also called as Tower of Brahma or Lucas Tower. It is a mathematical puzzle having application in the computer algorithms and program as well as begin used in psychological and medicine field as well. Earlier I have told that it is a mathematical puzzle. Here you can see the following rules are to be what is the problem of statements? Here given three towers, peg, pole and end disk of decreasing sizes. Move all the disk from one pole to the another one without ever putting a larger disk on the smaller one. Next, what is the statement to be solved? The initial state of the puzzle is when the disk is in the ascending order, that is smallest disk being on the top and is catched on the first pole. This is one. Then for this what I should do, there are some condition to be followed. When I told this statement and after this you will feel that oh, this is very simple, I can do, but there are some condition to be followed here. What are those conditions? The following rules are to be followed while solving the problems which make it more challenging and interesting. First condition. What is the first condition? Only one disk can be moved at a time. That means you cannot take 2, 3 or 4 disks. You should pick up only one disk. Then what is the second condition? A larger disk cannot be placed on the smaller disk. This is little bit challenging and interesting. Next, third point. What is that one? Each move involves taking the disk at the top and placing it over another stack or empty pole. That means you can use another pole. Note, what is that one? If you have n disk, the minimum number of moves required to solve it is 2 to the power of n minus 1. If n equals to 3, you will require 7 moves minimum. If you are in your case, let us take n equals to 3. Now let us name the poles serially as A, B, C, with A is beginning the source pole and C be the destination and B will be the used as spare pole. Now you can see here diagrammatically I have taken A, B, C. These are the poles and these are in the ascending order. You can see this what you can see here, this should be the same output here, but the condition is here you cannot place. You can see here three colors is there. One is green, blue, or you can tell that one is purple and another one is orange. You cannot place green above that these two colors. This is the very important condition. Here I am telling that how it is solved. Initially the state of the problem is like this. What is the first move? First I will take this green disk and because it is a smaller one, I will place it is at the C, that is destination. I have told that this is I have taken as a B as an a spare one. After that what I am doing? After I am taking B and placing in spare part. This one blue color you can see. After that what I am doing? I am picking this C and placing in B. See, here you can see. After that, what I am doing, I am moving A into C because it is empty. See, this is here I have placed. See, you can see the diagrammatic. Next, what I will do? Next, I will take this green and I will place it into an A. See, you can see. Now, finally, what I will do? I will take this B and place it into in a C. Now you can see it is in ascending order. Now what is left? Only A is left. This A is taken and it is placed above this, that is blue. Here you can see the first slide and you can see the 8th slide. The input and output is same. How much total I have moved? 1, 2, 3, 4, 5, 6, 7. That is 2 to the power of n minus 1 moves. 2 to the power of n is here, n is 3. Therefore, 2 to the power of 3 is 8 minus 1. That is 7 moves I have moved to make output as same. As in the above, that is diagram, we have moved the 3 disks following all the rules in the minimum numbers of step for n equals to 3, which is 7. The recursive task is to keep moving the disk from one pole to the another pole. Let us see how we shall arrive at our base case and recursively case for our program. As stated initially, our object is to move all the disks placed on pole 1A, that is, we will take that one as source pole, to the destination, that is C1. What I am doing here, to transfer all the disks from A to C, we should have to move the two upper disk, that is n minus 1 disk from A to B, which is the spare pole. Now, once n minus 1 disk are placed on spare peg, we can now move the largest or last, that is the nth disk, onto the destination pole C. The last set of the task could involve moving disk from spare peg B to the destination peg C. Thus, our case have been derived and they are as given below. What if n equals to 1, move the disk from A to C using B as spare. Recursively case. Now you can see how much I am explaining all 7 things. Move n minus ring from A to B using C as spare. Now nth ring from A to C using B as spare. Now n minus 1 ring from B to C using A as. Now you can see the program here. Right, to solve tower of Hanoi. Here I am taking int as number as integer variable and ndl1, ndl2 and ndl3. These are the 3 poles that I am taking that one as character. If n equals to 1, that means only one disk is there. Directly I can move from A to C. Then if it is not recursively, I am seeing n minus 1 moving from ndl1, that is disk 1, disk 2 and disk 3. Move disk from needle percentage %C to percentage %C because here you can see the character. Therefore, where from needle 1 to needle 2. Tower of Hanoi. Next, this is a function I have called n minus 1. Next 3, next 2 and next 1. These two functions are recursively called. After that, you can see the main function. I am taking elements to be entered. If it is there, n equals to is less than or equal to 1, there is nothing to move. Else, non-recursive function tower of Hanoi, that is I am A, B, C. I am printing the recursive function Same thing, number A, B, C, return 0 and close brace, that is end of main run. What will be the output? You can see that is A to B, then A to C, B to C, then A to B, C to A, C to B and A to B. See here 1, 2, 3, 4, 5, 6 and 7. Totally I have taken 7 moves to move from a source to destination. Thank you.